Welcome back, everyone. In this episode, we are going to take a look at this FBI Homicide dataset. We're going to be using Pandas, Matplotlib, and some custom functions we're going to work with to see how we can analyze the dataset. First, I would like to take a look at the dataset itself. It's combined into three spreadsheets. We have the totals, which has the country, the homicides, the total homicides, region, and subregion. We have guns, which again has the countries and total gun deaths, gun homicides, etc. So notice that the key value for both of those is country. When we look at GDP, we have the key value being rank, and then we have country. So this is, as far as Python and Pandas are concerned, this is the index 0 column, this is the index 1 column. So now that we have that out of the way, let's take a look at the code. I'm going to, instead of writing the code as I normally do, I'm just going to look at the final results and I'm going to explain it. I'm hoping that this way I can keep the videos a little bit shorter. Of course, all the material is available to you on GitHub. Just look at the link below and you can download the material. So let's start by importing Pandas. Notice I'm not giving it an alias, although when I import Matplotlib PyPlot, I am calling that PLT. Also from IPython display, I'm going to import the display method. Over here, I'm going to use the display method, as you can see, when I put the link up here where you can go and read more about it. So anything that can be displayed in HTML format, I want it to be displayed in HTML format. And I'm going to set the precision, the decimal precision, to be 2 decimal places. Let me do Shift Enter here and Shift Enter here. To read in the data, we can use Pandas read CSV, which, as you can see, has this format. The separator is a tab in these files. So I'm going to put a \T. Of course, if it was a comma or semicolon, you can just put those in. Pay attention that for totals and guns, I am saying that the index column is 0, but for the GDP, the index column is 1. As you recall, that was the country column. So let me read those in, and let's take a look at the first 10 in each one. So it created these data frames for us. There is the totals, there is the guns, and there is the GDP, which is great. Notice that because we said the index column is over here, index column is 1 for GDP, that just like the other two, it picked the country to be the index column and pushed the rank to be a regular column. I can now combine these three using the join method by saying totals, join guns, join GDP. Because I'm using the same type of index, that is the country, what Pandas does, and this is beautiful, it joins these together and finds the countries and match them up for us automatically. In other words, even though these are not in the same order in the three data sets, when I call join, it uses the index and matches the joins for us, which is great. So let's take a look at creating this data frame called data, and let's take a look at the first 5. When you don't put a number in there, it's going to give you the first 5. And we can see that it really appended the three of these together. I can see that because I see that, for instance, the GDP or GDP, etc. are showing up at the very end. I would like to create a new column called gun%. To create a new column in a data frame, you just give it a name, put it in quotes, single or double, doesn't matter. My gun% column is the gun homicides divided by the homicides times 100. So let's do that. And we can see that that was added to the very end. There is gun%. Moving right along, there are some unneeded columns. I don't need unintentional, undetermined, and gun suicides. So I'm going to remove those by calling the delete command. And if I look at the first 5 again, you see that those columns were removed along with their data. I also don't like to deal with anything that's not a number. It doesn't really do me any good. I can't assume 0. So I'm just going to remove those from the data set by simply dropping them. Again, I'm going to let data.drop NA, and I'm going to assign that back to data itself. And if I look at the head, you can see that anything that was not a number has been removed at this point, which is great. Pandas does have this warnings that occasionally when you do something, it throws a warning at you. I don't care. See these warnings. You can always import warnings and then call warnings.filter warnings ignore, and it will ignore them. So let me go ahead and do that. Now I'm going to create a new data frame called top 5, and this is going to call the lock method of the data frame. I'm going to get all the rows. That's what the colon by itself means. Now I could say colon 10, for instance, and would give me just 10 rows. So that's one way of doing it. I'm interested in just 2 columns, homicides and gun homicides, and I'm going to slice the result to the first 5, and that's top 5. Let's take a look at that, and we can see that in fact we got all the rows. Normally we would get those, except we sliced it, and we just got those 2 columns out of our data frame, our original data frame. I can now call the plot method of a data frame because this is a beautifully looking data frame. I can plot that, and the default is going to be a line graph, and I'm going to call matplotlib show. You can see that it shows these 5 countries, and it created the scale for us based on the values that are here. It shows the homicides and the gun homicides. This is showing it by countries. We can see Honduras is quite high and Colombia is considerably lower, although that's still a very high number. This is not the best way to look at this data set, and the default when you don't specify something is a line graph. If I want a bar graph or a pie graph, I can put those, I can specify those. Let's take a look at this in bar format. Now this is much nicer for this particular data set. I can see the countries and I can make a side-by-side comparison of the homicides versus the gun homicides. So this is all the homicides, these are the gun homicides, which is nice. What I'd like to do is show both of these together, so total show up as just a stacked chart, which would be kind of nice to see because the homicides readily includes the gun homicides. Let me go ahead and create a new function over here, and let's take a look at this. This is called plot per capita. We pass to it a data frame, and if they don't specify how many countries, we're going to assume 10 countries, but of course they can always pass one. This data frame is going to use the lock method like we did before. All the rows, homicides and gun homicides, up to the limit that is they want. Now notice I'm going to create something called total homicides, and this is homicides minus the gun homicides. I'm going to take this and subtract this, but then I will stack this on top of that, so I'll get the same result, but it's a stacked bar chart at that point. I can now delete the homicides column. I don't need it anymore, and I'm going to create a bar graph that is stacked, and then plot this per give it a label per 100,000, and then show it. Let's take a look and see what this does. You can see I'm getting the same value that I had up here for this blue chart, but now these are put together. They're on top of each other. Which I think is kind of cool that we can do that. Now I specified only 5 countries here. If I don't specify something, it's going to assume 10. If I want to get the top 3, I can just do that. I get the top 3. Of course, if you get too many in there, then it becomes sometimes difficult to analyze. You have all these countries in there, but you do have that option, obviously. I'm going to stick to my 5 and do Shift-Enter to see the results. Let's create another function called display relevant. And what this is what we did earlier with the top 5. Up here I had top 5, and it was data.lock, and I did everything, the top 5 here. So I'm turning that into a function, and I'm going to call the def.lock and get these. If they don't specify a limit again, I assume 10. So you see that this does the exact same thing, but now it's a function. So I can just call the function and pass to it a data frame and the number of returns that I want, and I get that. I'm going to take this data set that I have and look at the gun percents and plot that. Now this is not going to be very pretty. This is first the country names are running into each other, and obviously this is the gun percent for all of these countries, so it's kind of crazy the way it's set up. So what I can do is I can do what I've done before to create a function. So I'm going to create a plot percent, pass to the data frame, and again limit the countries to 10 if they don't specify one. And I will call my gun percent, so data frame get the gun percents, but I'm going to limit it to that number just like I did over here. I thought I did. I guess I didn't. I apologize. But I'm going to limit it to, say, 5 or 10 or whatever, and then I call the plot method on that. I'm going to specify the limits from 0 to 100 because we're dealing with percents, and then give it a title and show the graph. So if I graph this now, this looks a bit nicer, a bit cleaner, because I'm looking at just the 5 countries from this data set, the first 5 countries. And I can see the percent gun homicides. You can see Guatemala is basically 100%, so all the homicides appear to be weapons related. Let's take a look at creating a data set called top. Now this is a bit of a misnomer. I'm calling the data frame that I've created data. I'm calling sort values on it and ordering by GDP. Now this is going to be by default from low to high. So top, of course, means the top of the data set, so it's going to show you the lowest stuff. Let's take a look at that. You can see that I see Kyrgyzstan, Nicaragua, Uzbekistan, Moldova, India, etc. And you see that GDPs are going up because it's sorting it from low to high, and that's the default sort order. You may recall we went over negative indexing in Python, which of course works just as well in Pandas. And if I say minus 30 colon, this is going to get the last 30 in this list, which, as you might expect, are the ones that have the highest GDP values. Let's actually take a look at that. So yes, we do see that we have Greece, Malta, Slovenia, Finland, Belgium, Germany, United States is here somewhere. There's United States, and the top one is Luxembourg with 89, almost $90,000 GDP. So that we know how to do that. Let's make this sound a little bit more natural. We're going to recreate top as top minus 30, which are the top 30 countries by GDP. So let me go ahead and do that. And let's take a look at it. We should get the same exact result as we just had, and we do, which is great. So now that I have that, I'm going to say top by guns, and I'm going to call sort values. I'm going to do this by gun homicides, which is right here. But I'm going to sort this in ascending equals false, so the highest is going to show up first, and then all the way down to the lowest. If I do this, I see that the United States does have the highest one when we're doing it by gun homicides. Israel is after that, but it's a distant second, and we have Canada, Luxembourg, Greece, etc. We created that display relevant, as you recall, and I can now pass this data frame. Instead of passing the main data frame, I can pass top by guns data frame, which is a subset of that, and take a look at the first 5. So I can see that the top countries by homicides and gun homicides, as far as the highest ones with the GDP, the ones that are the wealthier ones, United States tops the chart, and Greece is number 5 in that. Because we have plot per capita, let's take a look at plot per capita for this set, also the top by guns, and we can see that United States again is the highest one. Now compared to Guatemala, etc., this is considerably, smaller as far as the percent goes. But within the industrialized and wealthier nations, the United States is tops. And then we have the rest of them, as you can see. Now, this is the total homicides is showing the whole thing. I can see that, for instance, Luxembourg, for some reason, has a pretty high homicide rate, relatively speaking. But a lot of it is not by guns. I mean, the gun percent is less than, or about 0.5%, whereas in the United States is about 3.7%, so it's considerably higher. And that's the end of it. I hope you enjoyed it. I hope you have a better idea of how to use some of these, Matplotlib and Pandas tools and graphs to do your data analysis. If you're enjoying these videos, please share them with loved ones and friends, and I'll see you in the next video.